So my talk tried to focus on prenatal chemical exposure, especially like endocrine disrupting chemicals. And I tried to introduce some of our findings related to children's neurodevelopment. But of course, children's neurodevelopment might not be the same as the dementia or Alzheimer's disease in later life, but just to think about some of the endocrine disrupting chemicals might associate with the children's health, and try to connect the current findings and the aging at later life. So this is the outline of today's talk. And let's start from the early life environment and aging. So as you might already know about the Dohart's theory that the risk of diseases at any stage of life is determined by the interaction of the genetics and cumulative exposure to environmental factors, which could be defined as the exposomes and lifestyles throughout life. And the influence of developmental disruption on childhood and adult onset brain and behavioral disorder may be connected. So we just the early life stage, we exposed to many kind of different environments. Yeah, I'd like to focus on chemicals, but of course not only chemicals, but also like tobacco and lifestyle and socioeconomic status and stress. It even started before the birth, I mean in utero, and then after birth there might be lots of different diseases onset, and it could be associated with the genetics as well as epigenetics, and many different diseases can be onset at later life. And I saw the very beautiful slide from the past two presentations. Mine is a little bit bored, but of course the neurodegenerative diseases such as Alzheimer's and dementia can be potential modifier risk factors. It can be many different diseases like type 2 diabetes or like blood pressure, also like dyslipidemia or midlife obesity or cardiovascular diseases. And as for the biological mechanisms behind, it could be like alteration of the hormones or metabolic functions alteration, also like oxidative stress or alteration of DNA methylation. And these kind of biological mechanisms can be occurred due to the environmental factors such as in utero conditions or dietary lifestyles, and also like stress, tobacco, and more or less endocrine disrupting chemicals. So most of the studies of the Alzheimer's diseases start from the taking a look at the patient and try to look back to the past, what happened or what kind of exposure can have happened before. But in my story, as based on the birth cohort, I try to take a look at the early stage in utero and try to look forward and what's going to be happen in the future. So some literature, I took it from one literature, like endocrine disrupting chemicals can induce the neurotoxicity, and most of the studies has been done based on in vitro or in vivo animal and in vitro studies. And of course the studies in epidemiology is very much limited, but there might be some evidence that endocrine disrupting chemicals, prenatal exposure, might induce the adult diseases. So from here, I'd like to introduce one of the birth cohort we are conducting in Hokkaido. So we call the Hokkaido study on environment and children's health. And actually, we do have two different cohorts, totally different participants. So one cohort is Sapporo, based on Sapporo city, and we recruited a pregnant woman from 2002 to 2005, and over 500 pregnant women were included. And the another cohort we do have is a Hokkaido birth cohort, and here we recruited from 2003 to 2012. It took about 10 years to recruit over 20,000 pregnant women. And here's the map of Hokkaido, and you are here in Sapporo City. And actually we have recruited pregnant women from all over Hokkaido area, along with the 37 hospitals and gynecology clinic. So objectives of the studies are quite similar in these two cohorts: to find the effects of perinatal environmental factors on birth outcomes, including congenital anomalies and growth retardation, and to evaluate the prevalence of allergic diseases and developmental and neurobehavioral disorders, and to identify a high-risk group classified by genetic susceptibility such as SNPs, and investigate transgenerational epigenetic effects such as DNA methylation. And of course, last but not least, to provide scientific evidence for health policies based on human epidemiological data. And this is a cartoon of the cohort profile. So we recruited pregnant women and collect some of the blood specimens. And after birth, basically we follow up the children, mainly using their questionnaires, but not only questionnaires. We tried to do the face-to-face examinations. And throughout the cohort, we collect some biosamples such as maternal and blood and cord blood and children's urine and blood recently. And we also visit some homes to collect some house dust and tap water. And we do like face-to-face examination, and most of the time we also use the questionnaires and try to find several outcomes, including neurodevelopment, body size, and endocrine systems, and asthma and immune functions. And these are some of the targeted chemicals we have already measured in the past decade. So as for the persistent organic pollutants, most of them have been already banned by Stockholm Conventions, such as dioxins and PCBs, organochlorine pesticide, and now PFAS has become a very big issue in Japan as well. And for short half-life chemicals, we do have some like phthalates and bisphenols and phosphate flame retardant. I believe tomorrow Dr. Yu Aitbama will give us another presentation focus more on the exposure side from the Hokkaido study. So we have already published many outcomes, but I cannot go all things. So today I'd like to focus more on the outcomes of the neurodevelopment. And as for some of the biological mechanisms related from the endocrine disrupting chemicals and adult diseases at later life, I'd like to introduce a study of the steroid hormones and DNA methylations. So this is a slide of the Sapporo cohort that we have measured several different chemicals in maternal blood, and definitely mothers are exposed to many different classes of the chemicals. And remember that mothers we recruited were very, very generous and not high exposures or not occupational exposed pregnant women, but just general women from Sapporo City. And actually the exposure level were relatively low compared to some of the other studies conducted in the United States or Europe. And take a look at the early stage neurodevelopment, dioxins, and this is the result of the dioxins and PCBs and Bailey scale at 6 months. And we have measured several different congeners of the dioxins, and definitely when the exposure levels increase, there might be some delay on the mental and also psychomotor index. That means that dioxins and PCB exposure in utero may delay the neurodevelopment among children at 6 months. And in context of exposome, or well, it's not the omics, but where we take a look at the mixture of the dioxins and PCB, we also find that the decreasing trend, which means the higher levels of the mixture of the dioxin and PCB may delay MDI and PDI. So if you expose, of course, most of the dioxins and PCB are correlated each other, and if you're exposed to the mixture, and when the mixture becomes higher, you may have a delay on the children's neurodevelopment. But interesting part is when we follow up the children up to 18 months, most of the association disappears. So at 6 months of age, there might have some delay, but at 18 months, there's no adverse association. So we interpret this result. It might be because the dioxin and most of the dioxin PCB come from the fish in Japan. So if we have, or if mother have a fish consumption, it can be a very benefit to the children as well as a good nutrient, especially for the unsaturated fatty acids. So maybe at the low level of dioxins PCB, the beneficial factors of the fish intake might be covered or masked the adverse effects of dioxins and PCB at 18 months of age. We also examined the association between the chlorinated pesticide and Bailey's at 6 months and 18 months. And we only found that the single association between cis-HCE inversely associated with the MDI at children's age 18 months of age. But among lots of chlorinated pesticides, this is the only one association we have found, so it might be chance findings. But the interesting part we should consider is that most of the chlorinated pesticides have been banned in 1970s, so the mothers not very much exposed directly, but because of the long persistency, we're still exposed to these kind of pesticides. So we cannot ignore, once we use, it can just keep exposing the people. We also take a look at the PFOS and PFOA, and we found that there's a very slight significant inverse association between the PFOS and PFOA and MDI at 6 months of age, but association was again not very clear, and so there might be another chance findings. And we also examined about the phthalates, DEHP, and there was no associations between the prenatal DEHP and Bailey's score at 6 or 18 months of age. Then we keep going with the age, and we examine the KABC and dioxins at 42 months. So again, dioxins very much associated with the 6 months the adverse, but 18 months there was no association, and 42 months actually we found there's kind of positive, the beneficial association. I would not say that dioxins is beneficial, but the direction is kind of protective or good way. So again, maybe the most of the dioxins came from the fish intake, and mothers who have a higher education try to eat more fishes. So we have good beneficial of the fish or nutrient rather than this very, very low exposure of the dioxins to children. And this is the phthalates and SDQ at 5 years of age. So a prenatal exposure to phthalates may increase slight risk of conduct problems at age 5, but again, the association is among many examinations, there's only one significant, so it could be the chance findings. So the phthalates is not so much adverse effect in this cohort. And finally, for PFAS, we can find a slide of the positive or protective association to the ADHD's suspected score at 8 years old. So again, I would not say PFAS is good for children's health, but there might be some other potential mechanisms such as inflammation and also immunotoxic kind of associations. And recently I found that also in NHANES there's slightly protective association between ADHD and PFAS. So in this very low level, the association can be covered or masked by other confounding factors. And this is the last outcomes of the neurodevelopment. So we also examined about event-related brain potentials, ERP. So in this study, we were measured the ERP, and at the same time, we have a task to the children, and we have targeted, and standard, and non-target. So when in a screen of the computer, and children found that the target, the children need to press the button, and we try to capture the automated attention and also voluntary attention allocated process of the P3A and P3B. And this result, we found that both P3A and P3B amplitude is decreased with decreased with dioxins. I'm sorry. Okay. So we found that inverse association with the P3B and P3A. So dioxin. So the ERP capture very small changes in the brain. So it's still difficult to interpret results, but even the phenotypes, it's very difficult to see the association between the chemical exposure. But when we use the ERP, the system might capture a very slight difference in brain. So from here, I would like to move on to more mechanistic part. So when we examined about the exposure level in utero and steroid hormone in cord blood, we found that several alteration of the steroid hormone at birth. So some chemical may increase or decrease cortisol or cortisone, or could be the testosterone, or increase of the estradiol. So the prenatal chemical exposure might disrupt some of the steroid hormones. And also when we take a look at the DNA methylation in cord blood, this is the result of P4 and P4, and definitely prenatal P4 and P4 may increase or decrease the DNA methylation in some genes. And of course, this is only at birth, so it's very difficult to interpret what can happen in the future life. But at least we found some of the alteration at birth from the P4 and P4 exposure. And lastly, this is the result of BPA exposure in utero and DNA methylation in cord blood. And again, we found some of the DNA methylation increase or decrease at birth. And especially for the exposure to the BPA, the alteration of DNA methylation is different between boys and girls. So some of these endocrine disrupting chemicals effect might be differ between boys and girls. So here's a summary of the findings. So we find some of the exposures in utero and may disrupt, or some of them are protect, but associated with the neurodevelopment at early life, And at the same time, it will alter exposure to chemicals in utero may alter the steroid hormones and also DNA methylation at birth. And actually, in Hokkaido birth cohort, we are now at the children's around age of 12, teenage children. And in Japan, that adult age is 18. So now we try to switch the participants from mothers to children themselves. So we try to recruit more children to follow up until later age. And also we try to do some face-to-face examination, especially to collect blood samples. So in the future we hope that we can measure many different kind of biomarkers which may associate with more health outcomes. So to finalize my talk, my presentation today is only from in utero to up to 8 years of age, and I introduced some of the findings we already published, but of course it takes another maybe 50 years to develop for development and aging through lifespan until the onset of the neurodegenerative disorders after aging. But we believe that it's very important to follow the children as a life course approach. So instead of looking back to the past, what's happened as an exposure, but we have information about exposure at early life. So we try to look for the children and follow up until the onset of the diseases. I'm not sure we can wait for another 50 years or not. And of course, the future, our specific aim could be the knowing of the exposome, and when we can intervene or prevent such exposure, it may reduce the risk of the onset of the diseases at later age. So thank you very much.